This is the second video in a series where I'm talking about how to get a job working with FPGAs, VHDL, and Verilog. The previous video was how to write a great resume to get you in the door, to get you this interview. So now, you're in the interview. Congratulations. You wrote a great resume. Check out the previous video if you want to get some tips on how to write a great resume to get you in the door. But let's assume that you've been brought in and you're going to be poked and prodded by the interviewer, which is going to be me. I'm going to interview you. I'm going to give you some example interview questions in this video and try to get you kind of thinking about some common questions that you might hear in an interview for a digital designer working with FPGAs. So I have some example questions. I'm going to run through them. What I'm going to do is ask the questions and probably give 5 seconds pause. And what the purpose of this video is so that you can practice. So pretend like you're interviewing with me for your job. You can pause the video, give your answer to me. I'm not going to be able to hear it, obviously. We're not there yet with the internet, but maybe someday. And then just practice answering some technical questions. Treat this like a serious thing, and maybe it'll help you. It'll give you some ability to rehearse. Here we go. Welcome to the job interview. So happy to have you here. This is going to be a technical interview, and I'm just going to jump right in. Can you tell me, what are a few types of flip-flops? By the way, I should have said this. At the end of the video, I'm going to go back through all these questions and give you the answers. So if you have any questions, or if you're unsure, stay tuned. Great. Next question. Name a few types of latches, please. Can you describe the difference between a flip-flop and a latch for me? Now, why might you choose to use an FPGA in your design in the first place? What does a for loop do in synthesizable code? And does it work the same way as in a software language like C? Maybe explain the differences there. Can you describe a few differences between SRAM and DRAM for me? What is the purpose of a PLL? Describe the difference between inference and instantiation in an FPGA design. Tell me, what is metastability, and maybe something you do to prevent it? What is a FIFO? What is a block RAM inside of an FPGA? Describe to me how a UART works and maybe where it might be used. What is the difference between synchronous and asynchronous logic? What is a shift register in an FPGA? Describe some high-level differences between VHDL and Verilog. Tell me some things you should be concerned about when you're crossing clock domains inside of an FPGA. Describe to me setup and hold time, and what happens if they're violated. Talk about some of the differences between a melee machine and a Moore machine, talking about state machines. What is the purpose of synthesis tools? What happens during place and route? Can you tell me what is a SERDES transceiver and where might they be used? What is the purpose of a DSP tile inside of an FPGA? Right, those are the technical questions that I have. I'd also like to know, maybe tell me about some projects that you've done or some technologies that you've worked with. And here I just want you to just talk about what's interesting to you and what you've worked on. All right, so what do you think? How confident did you feel answering some of those questions? If you were able to answer all those questions, I think you'd actually do really well in a job interview. If you are a little unsure of some of the answers, well, stay tuned because I'm about to talk through them all. This might take a while to talk through all these questions. I'm not going to go into a ton of detail, so if you have more further reading, if you've never heard of the answer to one of these questions before, if you've never heard of a DSP tile, for example, you might want to do some extra research about that. But I'll just talk through quickly some of the an answer that I think would be good to give that would give me at least some confidence that you had some idea what you were talking about. All right, number 1. Name a few types of flip-flops. JK flip-flop, D flip-flop, T flip-flop. If you don't know what a flip-flop is, that's going to be a big problem for you. That's like the simplest question. So figure out what a flip-flop is. Name a few types of latches. SR, JK latch. And if latches are pretty fundamental concept, so read about that. Describe the difference between a flip-flop and a latch. Main difference is that a flip-flop uses a clock, a latch does not use a clock. In general, I never recommend using latches inside of an FPGA design unless you have a really good reason to do so, and most likely you don't. So don't use latches. Why might you choose to use an FPGA in your design? Well, there's a lot of reasons. Maybe you have a lot of I/O requirements and you need some really huge FPGA with 1,000 pins, which exist, and they're massive. Maybe you have some really high memory bandwidth requirements where you got to send and receive a lot of data through a DDR interface. Let's see. Maybe you have to do tons of math operations very quickly, so a lot of multiply and accumulations. Maybe you do some filters, high-speed data processing, image processing, things like that. Those are all great applications for FPGAs. What does a for loop do in synthesizable code? A for loop in VHDL and Verilog do not behave the same way as they do in C. In VHDL and Verilog, in synthesizable VHDL and Verilog, a for loop is used to replicate or duplicate instructions. It is not used to step through something one clock cycle at a time. It expands all of the logic that's inside the for loop and executes it all on the same clock cycle. And if you are unfamiliar with that, do some research. I created a page about it in Nanland. Describe the differences between SRAM and DRAM. SRAM is static random access memory. DRAM is dynamic random access memory. They're both used for storage of data off chip, so off your FPGA, they're external devices. The big difference is that DRAM is much faster and larger. And DRAM is more meant for large data transfers externally, so that are all sequential data transfers. SRAM is usually non-sequential, kind of random transfers to an external part of memory. Not a lot of them. Maybe you want to write 16 bits only externally at address 10, and then at address 1000 you want to write another different 16 bits, and at address 500 you want to write a different 16 bits, and you're jumping all around through memory. That's a much better application for SRAM. Versus DRAM is like, I want to store an entire image from this camera off chip. That's a great application for DRAM. Okay, what is the purpose of a PLL? PLL stands for phase lock loop, and it's commonly used inside the FPGA to generate other clocks. So you have a clock coming into your PLL. PLL spins it up to some high frequency, and then you can use dividers off of that high frequency to generate other clock frequencies used inside your FPGA. Describe the differences between inference and instantiation. When you infer some block, that means that you're writing VHDL or Verilog to describe to the tools, the synthesis tools, that you want a blockgram, for example. So you might create a piece of memory like reg, mem, 7 down to 0, and you make it 256 deep. The tools might infer a blockgram, meaning they think that what you want is a blockgram. They might infer it incorrectly and just infer a whole bunch of flip-flops and give you some memory that you didn't actually want. Instantiation is literally instantiating a blockgram component, which every vendor is a little bit different with how instantiation works for their primitives. So if you want to instantiate a Xilinx blockram versus an Altera or Intel, I guess now, blockram, they're a little bit different with their templates. So inference, one benefit to inference is that it's portable between vendors. So if you infer a block RAM over here and it works, and you infer a block RAM over here, Lattice and Xilinx or whatever, then you can port your code a little bit more easily between vendors. I should probably create a page about that because that's kind of an interesting concept. Okay, what is metastability? How would you prevent it? Metastability is some unpredictable or unknown state of a signal inside of your FPGA. So it happens a lot on bringing some signal, anything external, bringing it inside your FPGA, or crossing clock domains. These are the two situations where metastability can happen. And in general, if you just said the word like, oh, you double flop it to remove metastability, that would be a good enough answer for me to know that you understood at least some basics about metastability. I wouldn't ask you to write an essay about it or anything. What is a FIFO? FIFO is a memory storage element. FIFO stands for first in, first out, meaning the first piece of data that comes into it is the first thing that goes out of it. They're commonly used in FPGAs. They're usually made out of registers or block RAMs. They're common for storing up data temporarily or for crossing clock domains, things like that. That would be a good enough answer for me to have confidence that you have worked with a FIFO. One other tip, maybe while we're just talking about this, is like if you don't know an answer, but you've heard of something before, like let's say you've heard of FIFO and you know it means first in, first out, but you've never used it before in an FPGA design. I love to see people trying to figure things out in an interview. Even if you don't know for sure how to instantiate a FIFO or why it might be used, pulling on some threads in your brain, you're like, oh, it means first in, first out. So that must mean that the first piece of data that goes into it is also the first one that goes out of it. So maybe it's like a buffer of some sort that, working through some of those things, being upfront with the interviewer and saying, well, I'm not sure, however, and kind of going off from there, that's always great. Like, I would much rather you do that than just sit there and say, I'm not sure because I don't want to be wrong. Being wrong is most of being an engineer. What is a block RAM? Block RAM is a storage element inside of an FPGA. It's usually something like 16 kilobits, 32 kilobits. It can be dynamically sized to have different widths and depths and store some data 1 bit wide, 16K deep, or 2 bits wide, 8K deep. Commonly turned into FIFOs, dual port memories, things like that. I have a whole page on what is a block RAM. Check it out. Describe a UART and where it might be used. UART stands for Universal Asynchronous Receiver Transmitter. It's a super common and very simple way to get data in and out of an FPGA. It's low pin count, low bandwidth interface. If you want to go between like a microcontroller and an FPGA, UART's a pretty good candidate for that. I'm going to link to the text version of this page as well, which is kind of what I'm cheating off of here, to give you some of the more details, and there's further reading on that page too, so check out the description below. What is the difference between synchronous and asynchronous logic? Synchronous is clocked, asynchronous is no clock. That would be a good enough answer for that question. Most logic inside of an FPGA is synchronous logic, meaning it's registers. That's the bulk of your what the FPGA is made out of, and it's super common to use in most communication interfaces are synchronous based. There's a clock involved. SPI, I2C, USB, those all have clocks. Versus USB is SERDES, clock data recovery stuff. Anyway, UART is asynchronous, but the majority are synchronous. What is a shift register inside of an FPGA? Shift register is useful for creating some small delays, useful for doing something, waiting for some number of clock cycles, so you have some data coming in and it shifts down this shift register chain, and 10 clock cycles later it comes out. So it's useful for converting serial data to parallel data or parallel to serial, things like that. Describe some differences between VHDL and Verilog. You could just tell me which one you like better, which one you have more experience with. In general, VHDL is much more strongly typed than Verilog, so you'll get a lot more syntax checking in the compile stage, versus Verilog will just let a lot of things fly. You know, if you want to assign an integer to a 3-bit register in Verilog, sounds great, no problem, not going to flag a warning. If you do that in VHDL, it'll cut your head off. So strongly typed languages versus not strongly typed. Verilog looks a lot more like C than VHDL does. What should you be concerned about when crossing clock domains in an FPGA? Creating a metastability condition is the problem. If you're going from a slow domain to a fast domain or fast to slow, you just need to be careful and make sure that you don't lose any data along the way or corrupt the data. So often double flopping, changing clock domains is helpful, or using some sort of buffer storage element like a FIFO, for example, is great. And you can talk for a long time about that, so I have actually a link to how to cross clock domains successfully inside of an FPGA if you want to read more about that. Describe setup and hold time and what happens if they're violated. Setup time is the amount of time that the signal needs to be stable going into a flip-flop before the rising edge of the clock comes along to register it to the output. So and then hold time is the amount of time that signal on the input needs to be unchanging after the clock edge. So it's before the clock edge, setup, after the clock edge, hold. If those setup and hold times are not violated, you're good. If they are violated, you potentially create a metastable condition inside your FPGA where you can't guarantee the output of the flip-flop. Meaning, like, worst case temperature, worst case voltage, worst case blah blah blah. You might have a timing error. You might create a metastable condition. Timing errors are bad, and you should never have them. So make sure you don't when you go through your place and route tools, which I think I have a question about that. What is the difference between a Mealy and a Moore machine? They're both state machines that are used to control flow through an FPGA design. Mealy machines depend on the current state as well as an input to know where to go next. A Moore machine just depends on the current state in order to know which state to go to next. Personally, I like Moore machines a little bit better. I find them a little simpler, and so I generally use those. What is the purpose of synthesis tools? Synthesis tools is the tools usually provided by the FPGA vendor, and the purpose is to translate your VHDL or your Verilog code into discrete gates that the FPGA has inside of it. So flip-flops, lookup tables, multiplies, things like that, blockrams, translates your design. What happens during place and route? Place and route takes after the synthesis process happens, place and route is where it takes those individual gates and lookup tables and actually assigns them to a very specific, you go here and you go here, and routes them with wires on the actual FPGA. And the main thing that place and route is trying to do is trying to do a time enclosure, meaning it's trying to, given the clock rate that your FPGA design is running at, trying to make sure that all of the start and end points for signals is going to happen in one clock cycle. If it doesn't happen in one clock cycle, you're going to violate setup time, you're going to violate hold time, the propagation delay is going to be too long, and you're going to have a timing error. And again, timing errors are bad, so don't do that. SERDES. What is a SERDES transceiver and how are they used? SERDES stands for serializer deserializer. It's a high-speed way of sending data across a low pin count interface. It's commonly used for PCI Express, SATA, gigabit Ethernet, high-speed video applications, things like that. That'd be a good enough answer for me to be happy. If you want to talk more about SERDES, I like SERDES. Talk about it for a while. What is the purpose of a DSP tile in an FPGA? If you just said it does multiplies better, that's pretty good. Good enough. DSPs do fast multiply accumulate operations. So if you have a large filter design, for example, and you have a lot of taps off that filter and each tap is a multiply, you can push each one of those to a DSP48 tile in Xilinx, for example, and it will you'll be able to increase the clock rate of your filter. If you don't have DSP tiles, you can still do multiply operations inside of an FPGA, but you just won't be able to run it very quickly. You might have to take extra clock cycles to get an output, to get an answer. That's pretty much it. Talk about your own experience using FPGAs, talk about projects, talk about what you like, what you don't like, things like that. I recommend putting a GitHub repository on your resume to show some source code. So if people want to see some examples of what you've done, you'll have that there for them. Hope this has been a helpful video. If it has been helpful for you to practice some of your skills, please consider becoming a donor on my Patreon page, which I will link to in the description below. And if you want to practice working with FPGAs, check out the Go board. Go to nanland.com, buy yourself a Go board. One of those two or both would be great ways to support me and keep me making great content. Thanks.